Good morning, good afternoon, good evening, wherever you are. Thank you so much for taking time out of your day and joining us here today. Let me start by sharing my screen. So welcome to the DeepLearning.AI online mini event series for AI for Medicine learner community. I'm honored to be your guest speaker today. Look forward to sharing and learning from all of you as a community. As part of ground rules, we're gonna go through the presentation for about 20 to 25 minutes. Please go ahead and post your questions on the Slack channel. If you see a question that's already been asked and you want to ask the same question, just go ahead and upvote it so we can go through and answer those questions ahead of the queue as well. So without further ado, what I'm going to cover today is operationalizing ML in healthcare and the real world challenges that you see. You've all read my, let me minimize that window here. So you've all read my bio, but I thought in the spirit of community that I share a little bit more about myself, more personally. So I volunteer at TEALS, which is a nonprofit organization sponsored by Microsoft Philanthropies, where we teach computer science to high school children. And it is one of the most fulfilling and amazing experiences that I've had. I volunteered at a foundation called Isha Foundation. I occasionally get on stage and we have opportunities to sing and perform, and I love to be in the mountains. I'm on the picture on the right. That's somewhere in the Himalayas in the Leh Ladakh region, 15,000 feet or so, just enjoying a hot cocoa. But it's, above and beyond all of the professional things, I love to give back. And I think this is a great opportunity that DeepLearning.AI has created for me to give back to the community as well. So I appreciate that. So let's jump in. Today, we're going to talk a little bit about context and background. I wanted to frame the conversation, take 5 minutes and frame it so that we can all see the problem in a similar way. I'll touch on what are some of the differences between traditional software and machine learning software as you go through the life cycle. And then we'll talk about the role of ML code in production scenarios and cover real world challenges and best practices that I have learned along the way doing this for the past few years. So as background, we built a healthcare machine learning solutions for providers and payers. We built a lot of models along the journey, and a lot of times, we would do a proof of concept. We would get going on a proof of concept, and then the client would want us to turn that into a pilot or go to production. And that life cycle had a lot of learnings along the way, which I wanted to cover. We worked with all kinds of data. We worked with big data. We had over 10 plus years of data from some of our customers, seven plus years from some other customers, 9+ million encounters. That doesn't include, all the labs and the vitals and other data points that you might have, which really explodes the amount of data that you receive and have to work with. And of course, there's a lot of small data too. I mean, you get an Excel spreadsheet with 10,000 rows of data and someone says, hey, create a model. So a wide range of data variety and volume, if you will. The kinds of models we built for providers, for example, is around things like length of stay. How long do you anticipate or expect this patient to stay in the hospital once they've been admitted? Discharge disposition, right? So where do you think, at discharge time, where do you think this patient is going to get discharged to? Are they going to go to a skilled nursing facility? Are they going to go home? Do they have to go to the PAC? And elements of patient care through the patient continuum that tie very closely to the business in terms of reimbursements from CMS, and particularly for those of you that are in the United States, you will know that Medicare is a big part of how payments are made to providers, which are hospitals. And of course, for those of you that are not in the US, I'm pretty sure hospitals go through these stages where somebody comes into an ER and they have to make a decision very quickly of whether they need a bed in the emergency room or do they need to be transferred to an inpatient sort of a setup, inpatient being the hospital itself? So lots of different models, lots of use cases. And I think one of the double-edged swords with healthcare is the fact that there are an incredible number of use cases that you can go after, that it sometimes can be challenging to decide which use case should you go after. And of course, we also build recommendation systems. So these are programs, for example, that government of Singapore has publicly talked about in the open domain, where they have been able to provide wellness programs to their citizenry, and being able to provide direction and nudges to citizens to say, hey, there's a walkathon happening in your neighborhood, or they have all these programs that allow them to eat well, shop healthy as well. So part of that, we were delivering millions of nudges to many people. So that's the background, and sort of that's sort of what we have been doing. And to frame this right, we weren't the Googles, we weren't the Facebooks, we weren't the Netflixes. So I think when you think about some of these lessons we're learning, think about this more from a perspective of a startup trying to get into this space, and how that journey went. So just to frame traditional software and ML AI software. Traditional software, you all know, right? You have some data in the shape of variables, and you have a set of rules that you want to apply to that data. And then you write an algorithm that uses the data and the set of rules, and out comes a result. And that, in the most simplistic sense, right? It could be a functional programming method that you apply. On the flip side, if you look at the way we build ML and AI software, and all of you are very familiar with this, right, is we provide data as input, and we provide results, essentially the labels, as input to the process of creating a machine learning model. And what we do is we try to match the data and the labels, and hypothesize and come up with a hypothesis function that best fits the data and the results, and that becomes a set of rules. That's the image to the right. And of course, there's a lot of iteration and experimentation that happens inside that black box when you're building an ML model. So let's just say you've gone through and you prototyped and built a machine learning model that you think is really high value. So what do you do now? Okay, so you need to go and deploy this to production. One of the seminal papers that I would encourage all of you to read is called Hidden Technical Debt in Machine Learning Systems. If you have read it, it goes through a lot of details around some of the things that companies like Google have seen in terms of the technical debt that gets created over the lifetime of a model. Essentially, that paper points to the fact that only a small fraction of real-world ML systems is composed of the machine learning code. So as members of the community that are building these models, that want to change the world, that want to do good and or solve a business problem, right? Whatever use case you're pursuing, for that to be usable by end users, for that to be scalable to millions of users, you have to go to production. And this recognition and the framing of the fact that ML code is a portion of the larger ecosystem. So you might be wondering, what are the bigger ticket items? This is an image I created inspired by that white paper that I mentioned earlier. If you read from left to right, imagine a well-timed conveyor belt, which is really your process management, that is driving and dictating everything that happens through the life cycle of your machine learning model, right? So you're going through and you're collecting data, you're verifying data, you do feature construction, you do feature validation, and based on all of those things, maybe you get to a point where you have your model run an API call, or do a scoring for a particular use case. But surrounding all of that, right, you also have infrastructure that you need to manage and host. You have service configuration. You have to monitor all these services that you are hosting. So for that ML code to really create an output and usable by lots and lots of people, for your machine learning algorithm to be adopted, in other words, there's a lot of other moving parts that somehow, as data scientists, AI engineers, doctors, nurses, we need to be aware of, that we can we can enable our organizations to make that adoption easier. So let's go through the journey of, if you say you have a model and you're ready to go to production, operations, infrastructure, security, compliance, monitoring, management, there's a lot of these areas, and your operations team might start asking you questions like, well, what kind of infrastructure do you exactly need? Do you need, an 8-core machine with 64 GB of RAM, or do you need, do you need a 16-core machine? Is your model secure? Is your model encompassing any private data that you may not want to get leaked outside? Is your model compliant with our corporate security policies, right? And essentially the list of questions goes on. So hopefully by the end of this presentation, you'll get a sense for how to tackle some of these questions that you get ahead of time as you're going through your journey, right? So what did we do, right? So in my experience, we built out this platform, very simplistically put, where we target providers, which are hospitals, payers or insurance companies, and wellness use cases. We provide a secure data pipeline, we provide a feature construction layer, and we allow automatic creation of features so that a lot of iteration and machine learning can be accelerated. And essentially, all of this was built on top of Azure, Kubernetes, and Databricks, right? And this ultimately gave machine learning data scientists and AI engineers the ability to develop, test, and then roll out their models to production. So these are the areas that I want to touch on in terms of real-world lessons in healthcare. So data correctness and validation, machine learning feature construction. We'll look at model development and the life cycle of the model and what some of the challenges there are. We'll look at performance of the model and how do you think about the health of the model and the features that are coming in to your production deployment. And also, if we have time, I'd like to go into the need for having a service mindset and what it is, right? We'll talk a little bit more about that. So let's jump in. Hopefully that framing just gives you a perspective of a lot of the hard work that we do early in the life cycle for a machine learning model is also important to educate the rest of the organization and the rest of the teams that surround that model and its deployment into production. So data correctness and validation. So if you look at some of the areas, this area is huge, right? So given the time, I'm only able to cover a small set of these things. But there's syntactic and type correctness issues when you get data from a customer, either in a Excel spreadsheet or through Azure, through a blob store somewhere, or in AWS, right? You get data in a certain shape or form. And that shape or form has to match whatever it is you're going to get in production. So one example of the thing that happened is during an early POC, right? We got some data that had age as a feature. So most of you that are building models in healthcare know the demographics tend to be a good set of features to have in your model. So of course we built and used that age metric or age as the column and use that to validate or build and validate a model, which was performing very well. And now the next step was, hey, can you roll this out into production? And of course, when we went to production, what we found out that the production data set didn't really have an age column. It actually had something, it had the date of birth, and because of HIPAA and personal protected information, PII, we essentially had to make that that field, the date of birth field, excuse me, was also de-identified, right? So it was shifted by left or right, and there's all these techniques that you have in terms of protecting PII. So that distinction essentially meant that the model we built during the POC was really not appropriate. So we had to literally go back and rebuild the model. So thinking about not just the data that you get early in the project, but working with operations team and say, what set of the data that you're looking at now actually exists in your production environment becomes important. Of course, that's if you want to take that model to production. Ontology mapping is a very challenging problem for those of you that have been working in the space for a while. You know that mapping ICD codes, SNOMED codes, They're all different across different deployments of EMRs and also different institutions and organizations that you deploy. So if you have one customer tell you that the demographic or the sex of the patient is male or female, and we've learned some of this in class, right? We've sort of changed. We used one-hot encoding to change some of those columns from M and F to 0 and a 1. Some other customers might encode that as the full worded letter, right? Male and female, spelling the whole thing out. So if you're getting different ways of expressing the same data, how do you manage that, and what do you do about that in production? So it's an important pre-planning step where the teams can engage to identify and understand what ontology mappings are needed and how to factor those into production. Morphological correctness of data, it's interesting. Data values can be just completely off sometimes. Data can be really dirty. For those of you that have worked, I mean, we heard from Roger Stone last speaker that was here. He said he spent months trying to clean the data up, right? And he's not alone. In the industry, we find that 80% of the time that is spent on building a machine learning model is really around cleaning data and massaging data and getting data in the right shape. So having the data and knowing some of the semantic insights into what the data might mean is important, right? So a blood pressure reading of 800 is absolutely not meaningful. And if you're manually looking at it, if you're looking at it visually, for example, creating some plots, you might find these outliers and weed those out. What do you do in production, right? What do you do if your daily batch of data or your stream of data contains just the wrong number because of a bug in some ETL pipeline, right? And that's important for data scientists to think about, because data in, prediction out, it's garbage in, garbage out. So how do you put data validation tests and create unit tests for data, if you will, through your machine learning lifecycle becomes important. I'm going to go through faster here because I'm looking at my clock. Semantic correctness. If you look at a blood pressure reading, systolic, diastolic, the numbers, the quote unquote normal for adults may not be the same as normal for pediatric patients, right? So if you're building a model for adults versus building a model for pediatric population, you might think about these features differently. Feature construction, availability, and scale, right? So what do I mean by availability? The fact that you need an MSDRG or a diagnostic resource group for a patient when they're getting admitted, because that's the data field that's getting filled in the EMR and flows through the data pipeline, right, to the prediction algorithm. Assuming that those DRGs are available may not be the right assumption. Sometimes they're just not there at admit time, or sometimes a triage nurse might provide an early diagnostic that might get updated at a later time in the patient's care continuum. So how do you handle those kinds of situations? We had one situation where, and I think this is more for the product managers also on the line, where a customer really passionately argued for a particular item in the EMR that they were filling in that was very critical. They thought that was the most important thing, and to the extent that if you're not using this in the model, your model is probably flawed, right? That I don't know how to trust your model if you're not using this. Interesting journeys, and not to point any fingers, but I think what happens is the passion of the customer translates into a lot of work, but also at the same time, when we looked at the data told us a very different story. The data told us that while that field was being populated by nurses, it wasn't actually used anywhere in their operational pipeline, right? So I think looking at how do you bring feedback from end users into your machine learning model and incorporating that in a data-driven fashion becomes important in terms of just availability of features. And not all features may stay the same, like I gave you the example of age and date of birth. Scale is another factor, right? So we worked with very large data sets, and when you're looking at millions and millions of encounters and lab and vital data, our pipeline would take hours to go through it. And initially, in the prototyping stage, it was like, it's fine because we're trying to figure out what the model is and what are the right set of features that are required for that problem definition, right? But also over time, what happens, I mean, this takes a long time, but what happens from a customer perspective or the problem definition perspective, right, is these predictions have to be available in a mission critical way to your end users at some point in time. So in terms of scale, while we were running it for 3.5 hours, that may or may not be sufficient in your use case to say, well, it's okay for the pipeline to run for 3.5 hours, or maybe it's not okay, right? So I think factoring those is an important. Where does scale come into picture? Is we had this situation where the pipeline was taking forever to run and it wasn't going to meet our customers' SLA, right? So we had to figure out how to optimize the runtime for that whole pipeline for that particular customer. And of course, as part of triage and performance, cloud systems are so easy to scale. You can easily scale up a cluster or scale down a cluster. Now, in an organization where data science and operations teams are working closely together, that's one thing. But if you're disjointed, you could fire up and scale up your cluster significantly larger, imparting a significant amount of cost without being aware of the cost that is coming out of that scale that you're trying to use the clusters for debugging performance. So easy to auto scale, but easy to burn money. So ideas like cohorting become important, right? And in our case, what was going on was the machine learning pipeline was doing what it was supposed to do, but the data ingestion pipeline had a bug that got introduced over time, which was causing a Cartesian join between two tables, and it was exploding the data set, right? And the big lesson for us was, if we had just logged good telemetry and had good logging and telemetry that said, hey, the shape of the data that's coming in from the data pipeline just somehow exploded overnight. And I think that would have given us a lot of good hints, but it took us some learning and doing to get to understand that a bug in a different part of the pipeline could have significant impact to the ML pipeline itself and the ability for you to score in a timely way. Uniqueness of entities, we all make assumptions that entities are unique. If you expect encounter IDs to be unique, and if they're changing, that can have an effect on all of your downstream data pipelines and scoring pipelines. And if you're joining any tables, right, all those have impacts downstream. So if you are working with the assumption of uniqueness of values, I think it's a good idea to validate those assumptions as well. So for this section, the lessons learned, really data ingestion should be reliable. That means data is always available, right? If I'm expecting data every day, if I don't get a data drop today, what do I do about that? What does the model do about that, right? So reliable, consistent, fault-tolerant data is really important, and also managing those pipelines in a fault-tolerant way is important. So if one of the steps or stages in a pipeline or jobs in a pipeline fails, this is probably evident to a lot of software engineering programmers, right? That write scalable software. But as data scientists, we may not think about, oh, can I run the retry logic? And does it impact the model, right? If I rerun the job, how isolated are the data inputs to the model and the model scoring itself? Cohorting, again, is an example where if you have really large data sets, thinking early about which of the data is really relevant to the model that I'm developing. Having data negative age, right? Negative length of stay, post consult. I mean, some of these things just don't make sense. But should you filter them out? If you're dropping this data, what impact will it have on your model performance? And some of the stuff we already talked about in class as well. So the one takeaway I would say from all of this, if you want to take away, is logging and telemetry through your entire machine learning lifecycle is the most critical thing. Because if you don't monitor, you don't know what failed. And if you don't know what failed, you don't know how to fix it. And that can cause a significant cost in the life cycle. Model development is really focusing enough time on the problem definition, right? In the real world, oftentimes you think the problem definition is clear, but it iterates quite a lot. So it can be very frustrating if you are building a model, just as you go through 80% of the way, somebody says, oh, by the way, can we tweak this about the model? You know, I want to solve a different problem, or I want to redefine the problem. And as frustrating as it is, I think if there are systems in place that allow you to iterate and change faster, that makes your life easier, right? Machine learning developers and researchers often find new ML libraries to use, right? There's a lot of dependencies you can take. The field is a very fast moving field, and this is something you know, every platform needs to enable their machine learning teams to do. But as a data scientist or an AI engineer, if you're embracing a new library, right, some of the things from an operational perspective you want to think about is, what about the security of the library? So if I ran something like a twist lock scan on the library, how many vulnerabilities does it have that my organization policy wouldn't agree with, right? So thinking about security as you embrace new libraries early is helpful, right? And then when you're doing model training and evaluation, we often found that, you know, you have to train the model against your customers' data or whatever data you're getting. And then this poses interesting questions from an operations side in terms of the level of access a data scientist or an AI engineer needs for a customer's environment, right? This becomes an important operational issue. But I think as organizations think about embracing AI and ML, it's useful for IT teams to elevate data scientists. And that's why I put machine learning engineering here in parentheses. It's not just a data scientist and a model development engineer, but it's really somebody that understands how to build models, but also how to operationalize them and understands operational constraints in terms of access and how to stay compliant when you have access to production systems, right? Deployment configuration for a model is all around hyperparameters, versioning, which set of the data did I use to train it? And of course, as data keeps changing and you get new data over and over again, I think it's important to think about managing those dependencies between model and version. Okay, I'm gonna go faster here. Model performance is really around, you know, how does one version of the model compare to the other version of the model? A lot of us have looked at the precision recall during this course, trying to understand which model should I use given the use case. But as you iterate through versions of models, right, you also want to understand and track the dependencies, right? We would occasionally have 7 to sometimes even 11, 12 versions of the model. And for us, it was pretty painful to look at, you know, tracking all of those versions of model, what feature set was used for that model version, right? Which data set was used for training, which was the validation set. All of this really trickles down into trying to have a good versioning capability for your models and the dependencies, right? And each iteration of the model, we spent a lot of time with domain experts and getting input from not only domain experts like doctors and nurses, but also customer input, right? I think it becomes important to for adoption and deployment that the customer has buy-in to the model that you're building and has trust in the model that you're building for deployment. Deployment ready versus customer ready. I'll skip that in the interest of time. There's a lot that has to happen for a model to go to deployment. And then you can just be in deployment without exposing it to customers, right? So there is that stage and you can operationally control that. But getting to deployment is important because the entire end-to-end sequence of that events that I described earlier in that image of technical debt has to work for the model to be useful. So, and, you know, once the model is using the right data that it needs to use and it's scoring the right data set, and the data is arriving correctly, and then predictions are happening, and then you can think about a production stage for the model, and then how do you drive adoption of that model in production. So some of the lessons learned, I think I would say, as AI engineers and model developers, embracing change is probably the most important thing. Fail fast model development, tracking dependency artifacts. Some of these emerging technologies like MLflow and Kubeflow, there's a lot happening out there. So keeping track of those and seeing how can you educate your organization to help them understand what these technologies are that'll make your life easier, right? And also the life of operations people easier. Thinking about security, supportability, and maintainability of technologies you're embracing is important. And education within the organization of other teams also is important. I'm starting to get to a time. I think on the health side of it, what I'll say is, once your model is in production, monitoring the performance of the model is important, right? There's a lot of well-written content out there on data drift and concept drift that I think I'd encourage everybody to read from productionalization of models. One of the things we learned a lot is really measuring not just the incoming data and its distribution, which tells us, and just do some sanity checks, right? Gosh, were there really 800 patients that got discharged last Friday? Seems weird, but then a domain expert might come in and tell you that, no, that's actually okay because there is a higher volume typically on Fridays for discharge, because weekend staffing in hospitals is different than weekday staffings, right? So I think having those kind of real checks and balances around your pipelines is important. Looking at missing features in production and reporting, logging, telemetry become important as well. The idea for serviceability is, right, who should be woken up at 2 a.m. in the morning when your model breaks? So if you think about that question and you think about who all in the organization you need to talk to, so that you provide them enough tools and technologies, so you're not the one woken up at 2 a.m. But there's sufficient automation for others to help you scale that as well. So I'm going to skip this. The idea at the high level was your model is creating predictions, but those predictions get consumed downstream, either in reports or through an API endpoint. So that the job is not done once the scoring or the prediction is out there. From a customer perspective or a use case perspective, it's important to make sure that you follow the entire train, right? So again, how do you make sure you're monitoring all of those capabilities? Service mindset and culture, I think this can probably take a whole talk by itself, but really if you think about taking a model from POC, a proof of concept, to production, having the model is not enough. Making the model be useful in production, right, requires a lot of the things we talked about so far, but also it requires organizationally for people to think a little differently, right? Especially in fields like healthcare, where we work together across domains. A data engineer may not have the domain context that a doctor might have around a certain aspect of the problem definition, right? So how do you enable collaboration across different team members to come together in a way that is productive and that can enable you to embrace change and accelerate going to production as well? So we did a lot of things like service health reviews, and product managers played a very important role in enabling a lot of this throughout the journey, right? I know I rushed through the last few slides there, but I do want to be respectful of your time. Feel free to reach out to me, connect to me on LinkedIn, or reach out to me. If in summary, if I say, what we talked about so far, right, is you're building a lot of these POCs, the proof of concepts, and working through models. There's still a long journey from building that model to going and taking that model to production, where you can scale it and use it in a scalable way. And across the life cycle of that model, it's important to look at the data. It's important to look at the model development and the iteration that you do during that model development. And then also finally, when you roll that model out to production, you need to continue to monitor that model, the performance and the data and the feature health across the life cycle, so that you have a good understanding of how to take a model from a production version 1 to a production version 2 to a production version 3. Because between each of those versions, there's a lot of iteration, a lot of handshake that happens, especially in the healthcare industry. you need to bring in domain experts and work with your product managers and engineering leaders to enable that for you. So with that, I will stop and look at questions. Let me stop sharing. Please go ahead and ask your questions in the chat, and we can take them one at a time. Can you share? So Thomas, congrats. Sorry if I didn't say your last name right, but Thomas asks, can you share lessons learned on bias avoidance, bias detection, and bias reduction? This has been a huge topic. Of course, it's a huge topic in the industry, and of course, every model we built had a lot of debate and discussion around this, right? So the thing that we did with this aspect of ML was to have a quality control board, right, which was made of doctors and domain experts that really helped the data scientists understand that you just can't filter out these data because you don't have it available, right? Because that could potentially introduce bias into your model. So a lot of what would happen then is really working with the customer and working with the domain experts and bringing in those data that would augment the data set that would also help in reduction of bias as well. We actually also did a lot of manual verification as well. So as you roll the model out, you might have people on the other end that are consuming the model, and to work with the consumers of the model prediction to say, how is the model faring relative to your own judgment as a human being, right? And of course, human beings have bias as well. So very complex problem, but we brought in the domain experts and we had an uncompromising attitude towards making sure patient safety comes first. And if and then working and taking the time to get the data you need to address that. How open is medical community? Svetlana Grant asks, how open is the medical community in using deep learning models in production? I think this is a great question. This is a journey. I think of this as a marathon, not a sprint. I will say that there are a lot of applications for DNNs on the radiology side, on the imaging side, and there are a lot of companies that are doing that as well. But we didn't do any of that, so we didn't actually look at images specifically, right? So we were looking at patient health records and the patient labs and vitals and those kinds of data. In terms of deep learning models, we spent a lot of time with our customers, both educating them and partnering with them to help them understand the performance of these models, right? So a lot of time was spent on addressing MAE numbers that we get. So some of the things I talked about in the model development, Svetlana, around version to version, tracking of model performance, was also looking at MAE and RMS error and different area under the curve. So looking at all these metrics was just part of the journey that we went through, and then of course we would educate the customer and have that conversation with the customer. So I would say this is a journey. I would say that not all organizations are waiting with open arms to embrace this technology, but also if you look at some of the things that are happening because of COVID, we're starting to see change in terms of how people are starting to embrace these technologies as well. Okay, great questions. Thank you so much. Okay, any other questions? Awesome. If not, I want to give time back to you guys. So so think about some of the challenges think about some of the challenges that exist across the life cycle of the machine learning process and what role we can all play in enabling, educating our sister organizations to help them get to a point where they are able to deploy these models as well. Sam Kuchakula asks, any step in ML/DL processes to encrypt, decrypt metadata? Because of HIPAA and PII, data has to always be encrypted at rest and in transport. So you can't decrypt these data on the fly. What you have to do is ensure from an operational perspective that you have pipelines in place that are to begin with, right? And once you have the data center, so we had, for example, our organization was all HIPAA certified, and we had a BA agreement with our clients, so we could work with medical data in a safe way, in a compliant way. But as far as encryption decryption goes, it's important to have a transport and an on-disk state that is always encrypted for data. And you know, there's a lot of packages out there that do these encryptions. Okay, so guys, if there isn't anything else, thank you so much for taking time from your busy day. I hope this was useful. And again, you know, companies like Google and Facebook and Netflix, they are doing this at massive scale. But also, as you think about small to medium businesses and you think about how enterprises are adopting and embracing ML and AI, getting our models to be used by users and adoption for them is important. And a lot of what we talked about today is important for you to think about how to get your models to be production ready. And again, I'd encourage you to check out the hidden debt in machine learning. That link is in the deck as well. Okay, awesome. Thank you so much for your time. Appreciate it. You have a great day and have a great rest of the week or evening, whatever it is. Bye now.